Hi guys, today we're going to be looking at some multiple choice questions in the physical science paper 2, so the chem paper. Which one of the following compounds has hydrogen bonds between its molecules? So, the one with hydrogen bonds means there's an O bonded to an H, which is usually present in alcohols and things like that. So in this case, if we look at our four compounds, the one that has hydrogen bonds between its molecules is compound C, as we can see the OH group over here. Question 1.2. Which of the following is the correct general formula for the carboxylic acids? So, as we know, carboxylic acids always have two oxygen atoms. It doesn't matter how many carbon atoms, it always has two oxygen atoms. So we can already eliminate B. We then know that carboxylic acids have double the amount of hydrogen atoms that they do carbon atoms, as the two oxygen atoms take up some of the bonds of the carbon atoms. Therefore, our answer would be C, as it has double the amount of carbon atoms, so 2N. Question 1.3. Study the reactions below. Reaction 1 being this one and reaction 2 being this one. Which of the following combinations is the correct IUPAC names of compounds P and Q? So here in reaction 1 we see we have an alcohol and hydrochloric acid is added to it. Well, concentrated hydrochloric acid is used as a catalyst in order to remove a water molecule and form compound P. Therefore, if a water molecule is removed from reaction 1, we will then end up with an alkene. And as we can see from our formula, we have 1, 2, 3, 4 carbon atoms. Therefore, it is butene, and our OH group is on the second carbon. Therefore, when it is removed and forms the H2O, the double bond will be between the second and third carbon. So we will have but2ene. In reaction 2, we take compound P and we go through hydrogenation and get compound Q. So this is when we add an H2 to the compound. And this H2 will cause the double bond to break and form all single bonds. So we will then end up with butane. So our answer would be B. Question 1.4. The potential energy diagram below is for the following hypothetical chemical reaction. Which one of the following combinations of values for the heat of the reaction and the activation energies can be obtained for this reaction? So we can start by looking at the activation energies. So since we start here, the forward activation energy would be this part over here. And for the reverse reaction, our activation energy would be from here to there. Therefore, our reverse activation energy would be bigger than the forward activation energy. And as we can see, the energy of our products are lower than the reactants. Therefore, our delta H is negative. So if we take all of that into consideration, then our answer would be D, as we have a negative delta H and a lower forward activation energy than we do a reverse activation energy. Question 1.5. Initially, an equal number of moles of hydrogen gas and iodine gas are mixed in a closed container. The reaction reaches equilibrium at constant temperature according to the balanced equation. Which one of the following is always true at equilibrium? So, at equilibrium, we know that the forward reaction and the reverse reaction are equal, and we can see that we have 1 mole of H2 and 1 mole of I2. Therefore, the same amount is used of each to produce the 2HI. We can therefore determine that at equilibrium, the concentration of the H2 and the I2 are the same, and this is always true. Question 1.6. Consider the following reaction at equilibrium. Which one of the changes to the reaction conditions below will increase the yield of SO3 gas? So, if we add a catalyst, increase the temperature, or increase the volume of the container at constant temperature, well, actually, just the catalyst and the temperature, those increase the rate of the reaction. However, it does not change the amount of product formed. An increase in the volume of the container at a constant temperature also affects the rate of reaction. However, it doesn't affect the amount of product produced. However, the addition of O2 gas, as we are adding a reactant, will therefore favor the forward reaction and more SO3 will be produced. Therefore, our answer is A. The table below shows question 1.7. The table below shows the ionization constants Ka for 2 acids at 25 degrees Celsius. Consider the following statements for these 2 acids when they have equal concentration at 25 degrees Celsius. So, I, both are weak acids. II, butanoic acid is stronger than ethanoic acid. And III, the butanoic acid solution has a lower concentration of hydronium ions, H3O+, than the ethanoic acid solution. So, since we have a Ka value, which is less than 1, we know that these are both not weak acids. We can see that butanoic acid has a smaller value, a Ka value, than that of ethanoic acid. Therefore, II is true. Butanoic acid is stronger than ethanoic acid. That is my bad. I just read the whole table wrong. So, Ka is the acid constant. So basically, these two are both less than 1, so they're both weak acids. And butanoic acid has a smaller Ka value than ethanoic acid. Therefore, it is a weaker acid than ethanoic acid, causing it to have a lower concentration of hydronium ions. Therefore, our answer is actually B, and 1 and 3 are correct. That is my bad. Question 1.8. Which one of the following pairs of acids and bases, all of the same concentration, react to give the highest pH at the equivalence point in a titration at 25 degrees Celsius? So, if we want the highest pH, we need to have a weak acid reacting with a strong base, as the more basic the solution ends up, the higher the pH. And out of our 4 options, the one with the strong base and a weak acid is D. Question 1.9. A standard galvanic cell is set up as shown below. Which one of the following combinations of the metal used as the cathode and the electron flow direction is correct? So, if we look at our redox reaction table, we would be able to determine whether CD or Ag, or the ions, respectively, which one has a higher oxidizing energy potential and which one has a higher reduction potential. And if we look at that, we can see that the Ag is a higher oxidizing agent and will therefore be reduced. So, therefore, Ag is the cathode, as reduction takes place at the cathode. And this would mean that the electrons flow from the anode to the cathode, which would be from Cd to Ag. So our answer would be B. Question 1.10. An electrolytic cell is set up to electroplate an iron rod with nickel, as shown in the diagram below. Consider the following statements. The iron rod is the negative electrode. The metal ions in the solution undergo reduction. The anode is pure nickel. Which of the above statements is true? So, since we want to plate the iron rod, we want reduction to happen at the iron rod. And reduction happens at the cathode, which is the negative electrode. So we know I is correct. The metal ions in the solution undergo reduction would also be correct, as we want the nickel ions in the solution to be plated onto the iron rod. And then, obviously, if the iron rod is the cathode, the anode has to be pure nickel. So all 3 are correct. So our answer is D. And that's all for this video. Thank you.